so the fun fact of this talk is that I've been working on this talk since yesterday. During the MC sessions. So if it looks like I don't know what the next slide is, it's because I don't. So we're going to roll through this. There's live demos. The demo guides owe you one, so it may not work out well, but we're going to see. The title of this talk is Betting the Company on Go and Winning. This isn't an investor briefing. This isn't a sales pitch. I'm going to try to explain why CoreOS bet the company on Go and wins. So at a high level, this is my interpretation of what CoreOS does. We turn white papers into source code, and source code into products. All right, so when I got to CoreOS, what we talk about in Slack is like distributed consensus algorithms. And we actually build products that actually meet those things, right? So we settle disputes by looking at some of the white papers. And it's like the first job I've ever had where that was actually a thing you actually had to do. A little bit about CoreOS. At a very high level, we're in the business of building and shipping global-style infrastructure for the masses. So when people look at CoreOS, they look for us to deliver tools, utilities, an operating system, cluster management, and all those things so they can pretend that they're Google too. The truth is, you probably would never be at Google scale, but there's a lot of principles that you can use. Now, we have a distributed team. From Atlanta to San Francisco, where our headquarters is. My favorite office is the Portland office, where I work from home. Super awesome. Yes, that's fantastic. No meetings. Like, I didn't get that email. Sorry. All of our back-end projects are ready to go. Like, we're a complete go shop. I think you did an interview with us and you mentioned some other language. Might not work out well. But we don't try to write that all of our web apps in books. So we do have some AngularJS in it. So a little bit of background about our developers, right? There are no factory methods, but you might catch someone using bitmask for function arguments. And this totally pisses you off when you see this. Like, you look in there, it's like, how many things does it take? Well, you need to go and like find out. It's like a bitmask. You don't know what a bitmask is? Well, then why? It's go. Like, there's no reason to do this. And this is because a lot of our developers have C and C++ backends. A lot of them are former like kernel hackers, low-level distributed databases, low-level high-performance networking. The kind of networking where you bypass the kernel and hope for the best. So, one thing that you hear a lot in the Valley is, let's start a business and write everything to Go. Now this is before you have a business plan. As long as you write it to Go, your chances are really high that you're going to get funded. For this conference, there's only two things you really need to consider. If you're going to adopt a language, you got to consider the community and your actual business. If you're VC funded, you might be able to skip number 2. Might not be that important, at least initially. But the community is the focus of this talk. What we bet on was that the ecosystem and the community would be there. So when you think about the community, for us, it's like, we love the logo, but who are these people? And when you adopt this language, you got to know who the core maintainers are. You got to know who like the leading external contributors are, because they have a lot of say in what happens, right? Code doesn't write itself. So while the source is open, if you write no code or you don't give any feedback, you have no say, right? So that's a very important part of it. And along with that community comes code standards and code quality, code engineering. I've contributed to the standard library, and the code review you get for a one-line change is game-changing. Right? It's like you're allocating, it's a document change. And then the community drives the ecosystem, right? So if you have a great community, that drives what goes into the standard library, what third-party packages you see, packaging and distribution, tools, debuggers, IDEs. And for us, all of that, we have to think about, can we build a business that you would build your business on? So we're an infrastructure company. And our product has to work for you and run in your environment. So these are the things that we consider. So I'm going to give you a little bit about Go at CoreOS. A little bit of metrics so we can kind of level set here. We write a lot of really small utilities, tons of them. But this is about the ratio here, right? We have tons of repositories in GitHub. And over across those repositories, there are about 80,000 lines of code. Thousands of lines of C, not too much, but there are some cases where we have to drop down to C to do things. And we'll talk a little bit about that. And thousands of lines of JavaScript, and I'm so happy about the last one, like 0 lines of Java code. I don't think our check-in scripts will even allow. Like, it detects it, and it just doesn't let you push it. Best commit hook ever. I have a write Go code, right? So it's mostly a standard library. I think Blake Nazarani's in the audience, and I'd love to just talk about, like, if you're walking down the street, you just don't pick random stuff off the ground and eat it, right? It always surprises me how many things people just suck down from the internet and deploy to them. Like, I see people like, npm install the world, right? That's ridiculous. You're going to end up on CNN explaining why you got hacked. We use a collection of CI services and just a testing package. Nothing fancy. All of our tests are straightforward, and this has been really helpful when we're onboarding new developers. They don't have to learn a bunch of frameworks. You learn one thing, you're good to go across all of our projects. And we keep everything in GitHub, so private repositories for our commercial stuff. All of our binaries, we really push hard so that they can be statically linked. Now there's some things like our container runtime engine where that's not possible. We actually need the dynamic libraries to do some things. But in essence, we attempt to make sure everything can be dynamically linked or statically linked. And this is so we can have some good OS support across the things that Go supports out of the box. We want to just inherit that. But we do provide some wrappers for the community. So in all of our repositories, we have that a build script and a test script. What we found is when people come to the Go community, or coming to the Go community for the very first time, they don't know anything about the Go tool, right? So we try to help them out by having these high-level scripts. But we don't get crazy in here, right? We don't try to re-implement make files in bash. We make sure that everything in our repositories is still Go gettable. Now, we do manage our dependencies with Go dep, and we do rewrite import paths. Like, this is the thing I don't like, actually. Like, when I see this in code, it just really makes me sad to see, like, the rewriting, but it's something that we do. And really, I think the biggest thing we do talk about is dependency management. So my plea is, please let GB be the last Go tool that we actually need, right? So I think GB, when it was written, it made me really excited because it rethought a few things, it challenged a few things, and I thought that was perfect. Especially from someone like Dave Cheney, who I respect greatly. Like, you tell the Go team, like, no, we need to do something different here. And the thing I like that's in Go 1.5 is that there will be kind of a general consensus around how we do vendor, right? So all of these tools can exist, but the Go tool will be Go gettable if people use the vendor directory correctly. And one thing I'm most excited about is no rewrites. Is that still true? No rewrites? Perfect. So now I can say, like, Go for God himself said no rewrites. Why are we doing this? So the drawback to GB was that it did fragment the community. I remember I converted one of my repos, I was like, yay! And then someone was like, this is sad. Now I need to have 2 things. I didn't care, I still used GB. So I did ask the developers at CoreOS, I was like, hey, what do you guys think about Go? I'm doing this talk, and it'd be nice to have your authentic input. And they were like overly excited about this. They started printing and things like this. So at a high level, it's a little bit of bike shedding, but the top 2 things is GoDep is awesome. If you lose it long enough, GoDep sucks. And it's not really a knock on GoDep because GoDep is hard when everyone uses it. When there's some things like you're writing a library, you shouldn't use GoDep. Because then in my main package, I can't use GoDep because then I have to conflict with your things that you're bringing in. This becomes a really, really bad problem. And then it turns out when someone deletes one of those repositories that GoDeps is tracking, even though you have the vendor code, it just stops working. And it took us a long time to figure this out, right? We're like trying to do demos and it just doesn't work. We can't build a repository. But it turns out you got to make sure that doesn't happen to you. But the interesting thing is they have this journal. I'm going to call it a journal. Because they've been keeping this thing for like a year. I was like, you guys have a journal of what you don't like about Go? And they did. So what we're going to do is take a peek at that. Now, I had to change the title of the thing, so I can't take what the original title was. We're going to call it the CoreOS Go Journal for now. And overall, it was like, hey, Go is a time sink, and here's why. Now, the one thing I do respect about the team is we went through this, and people started linking issues to the complaints. Like, somewhere in our source code, we ran into this problem, And this allows us to actually give great feedback to people. Now, we're not saying all of this is accurate. This usually happens when an engineer starts banging their head on the desk, and it's like, oh my God, shadowy variables, thanks, Rob. So you start blaming the Go team. And then we keep this doc, and we just track all the things, right? So when we go through this, things like the inability to fork with namespaces. So we write some low-level tool. So our container runtime engine, we need to work with Linux namespaces, and not having the ability to fork screws us up here, right? So these things that we run into that most people may not run into, when we scroll down long enough, I guarantee you, how many people think generics are on this list? You see? Ooh. So we have everything here, like even language generics, right? And here's like the reason why, right? And you could say those are people's opinions. And I'm always curious, like, we showed up to Rob Piper, what he was saying about that. So, this is what I think Rob Piper would say about that. That's not my work, by the way, so I'm giving credit down here in this Twitter stream. I saw that and I fell off the chair. So how are we doing, right? So we make this bet on the community, and so far it's actually been pretty awesome. Even though we have a little bit of complaints, they don't stop us from getting things done. Our bet was to build great projects, right? So what's the outcome of that? So pretty much we have a Linux distribution, like a real Linux distribution, and all of our user land is built in Go, right? Now we do some C and C+ work where we have some kernel patches and systemd work. But all of our user land, we start to Go without a question. That's what we're doing. etcd is written in Go. We have this tool called Flannel, and I want to talk about that. I'll talk about it in the next slide. Fleet, Rocket, and Tectonic. So Tectonic is a shout out that I had to give so marketing can improve my trip to GopherCon. This is what we call it. It's how we turn these projects into products. That's the last part. So etcd. So etcd is a highly available key value store for shared configuration and service discovery. If you're going to become an infrastructure company, this is the first project that you have to do. HashiCorp is building. Like, you have to build a key value store. You got to prove your chops by building one of these, because it turns out for the system programming that we do is at the cluster level, this becomes a core piece to every product that we build. So one of the very first projects at CoreOS was to build a distributed key value store. We use it for configuration. CoreOS is a sub-updating operating system, so if you have 1,000 nodes in your cluster, the last thing you want them to do is reboot at the same time. It's hilarious for your sysadmins to see this happen. So what we do is we leverage etcd to gain a lock and have the nodes coordinate themselves, so one at a time, they come back up and they release the lock. So the thing I like to show is the key dependencies, right? So we don't do this stuff ourselves. And here's some of the key dependencies that we have. Now, the one etcd Raft is special because we rewrote Raft, and it's also used by CockroachDB, and it's something we see that will be shared throughout the community. But we also rely on a lot of other packages that allow us to move really, really fast. So a lot of our services look like this. We import like a standard set of things, and we just have such a head start when we're building these infrastructure tools. Like Go is like Rails for infrastructure tools. All the stuff you need is there. I don't think anyone wants to be Rails of anything, but it's nonetheless a really good head start for people. I was too lazy to put a diagram in here, but Flannel is one of the products that we built on top of etcd. And what Flannel does is this, like this just when you go to the website for your slide deck. And what Flannel does is it gives us this overlay network or network automation for containers. So we like to, our products revolve around this idea that they'll be running on one or more nodes. So we wanted an easy way, either using an overlay network or configuring routers to do that. So we built a project in Flannel. It's one of our low-level products that has to drop down to C in some cases. And here's the key dependencies here. And I think Netlink is probably one of the more advanced libraries in Go because of all the syscalls that need to be made. There's some undocumented stuff in some of the operating systems that you have to deal with. And Go kind of makes that stuff a little bit easy, so the Netlink package is really popular. We integrate with systemd in all of our projects, so that's a popular package that we do. And Flannel is one of the projects that leverages etcd for its routing table. So when we add nodes to a cluster, the routing table grows by using Flannel and storing everything in etcd. So if we lose a node, every other node has a consistent view of the cluster. Now, it's not all about doing it yourself. Right? A lot of people have this idea, you adopt a new language, you're just going to write all the things you need. You're just writing your own. And this is the spirit of this whole thing. Now this has video, and I'm not sure it's going to play. But just watch it, and I think this is what it looks like when you go edit it on. So that's the goal falling on him, that's technical debt, right? Every time you get the right idea that you're just going to write your own security or thing, it's just going to come back and bite you. That's what it looks like. It's so funny, we should watch it again. So keep that in your mind when you think about just rewriting it over from scratch. Alright, so the Go community that we rely on is very unique. Canonical, Cloudflare, Docker, Opal, HashiCorp, SoundCloud, Kubernetes, which is Google but its own entity, Weave. All of these infrastructure players have roads to dominance. When you think about modern infrastructure, like Go is the first thing most people think about. If you write a new infrastructure tool today in any other language, I think people will look at you crazy because it's like, oh, install instructions? JVM requirements? Dude, you rewrite this thing in Go. So that's what we're starting to see. So I'm pretty sure everyone in this room has heard about it. Has it? You haven't heard about it? Docker is like, to me, Rails put Ruby on the map. I honestly think Docker really put Go on the map for a lot of people. A lot of developers got their first taste of Go by downloading Docker. They're like, hey, this is cool runtime engine. Here's what you gotta do. It's like, that's it, one thing in. Put that one thing in there, you're off to the races. That was fantastic, and it set the tone for tools to follow. Now I want to demo Docker. So Docker is a great way of like pushing things to a server in a container. And what I have in the demo that I hope works, come on internet. You gotta say something nice for the demo guys. So I have these 4 nodes, and these 4 nodes are running Kubernetes, but they're also Docker hosts. And I remember watching a talk about system programming and Golang, and someone asked Rob Pike at a panel, and their panel had people from systems languages, C, Rust, and things like that. I'm like, how could you consider Go a systems language? I think if you rise above a single machine, it starts to make a little bit of sense. So I have these individual machines. I like to think of them as individual CPU cores. I can use Docker to deploy to one of those machines. And it's like pinning your process to one CPU core, right? So let me check on time here. Let's go back to our slides. We're wrapping up. And the next product that we have, and this is like a combination of a lot of things that CoreOS does. Kubernetes runs on the operating system. And this demo we'll be doing it on CoreOS. It's backed by etcd, so all the cluster state is stored in etcd. It has a global scheduler. How many people know what a scheduler is? All right, for those of you that don't, if you're a developer, you have sysadmins at your job. And those sysadmins are in charge of deploying applications to your servers. And you can look at them like your scheduler. And they keep cluster state in a database, normally a spreadsheet. And when they need to deploy something, they'll update the state. And I heard that if you give them pagers, they become highly available. I'm a sysadmin at heart, so I can do that. Alright, so Kubernetes is an open source version of, I would like to say Borg, but it's not 100% there. There's some new ideas there. It's backed by Docker. It also has support for Rocket, our runtime engine. Has self-healing infrastructure. But I don't want to show you the code. I want to show you the experience. So to me, at a very high level, this is what I think about Go being the perfect systems programming language when you consider the data center being the system. So what we're going to do here is going to deploy, the GopherCon website. Hopefully this works. So let's get to it. I need to find my terminal. So let me do something here. I want to make sure my routes are good to go. I've been noticing when I switch Wi-Fi, things stop working. All right, we have routes. There is a chance that this might work. So in Kubernetes, we have this idea of pods, and pods are these units of work. For right now, a very simple explanation is that they will hold our containers. One or more containers get co-scheduled to a host. Now here's my 4 hosts, and there's some resources. Something's leaking memory like crazy, but we have enough to complete the demo. So what we'll do, the rest of we can look at that later. So what we have here is we're going to describe our website. So we're going to have a replication controller. And the goal with this replication controller, we will describe what it means to have a GopherCon website. We're going to deploy version 1 of the GopherCon website. Grab the GopherCon container, schedule it to one of the machines in the cluster. If this works, we should be good to go, and we'll have the website. Should be good. So kubectl is a command line tool that gives us an interface to this thing. And what we're going to do is attempt to deploy the GopherCon website. So it comes back. So we have our definition in place, and we said we wanted one of these things. GopherCon, 9 o'clock, just kicked off. We just want to make sure the site was good. So what we can do is we can actually check for the number of pods. So we can get pods, and we see that we have one of them running. Now, it's somewhere in the cluster on one of the nodes, but I don't really care anymore because I'm going to treat the cluster as a single machine. So the next thing that I want to do here is create a service for it. So Kubernetes has built-in service discovery. When I deploy one of these replication controllers, it uses labels to track the pods running in the cluster. If the machine that this pod got scheduled to dies, it would move it to another machine automatically for me. So what I need to do now is have something that will proxy to all the nodes using the internal service discovery built in the Kubernetes. We won't have time to go into too much detail, but we'll make sure that we have a service in the system. Right, so it looks like I created one earlier. It's just another JSON definition telling the cluster that, look, I would like you to, in this case, I'm going to use a public port on all the hosts to give me a way to get at the service discovery endpoint, and it will proxy to the container running somewhere in the cluster. So what I want to do really quick is describe what that is. So describe services. If you see typos, be patient, I'll fix it. So we have this dynamic port allocated to us. So it picks a high port to avoid port collisions. You would do this totally different in production. This is for the demo. So I should hit this port and not concern myself about exactly where this thing is running. Let's come out of this mode. So what I'm going to do now is I'll just do a new window here. I'm going to hit one of the nodes in the cluster. So node 0, cluster blah. You can see I've been practicing a little. And if this works, it's a GopherCon site. You guys should clap because it took me all damn day to turns out there's like a function in the HTTP util package that says reverse proxy, but doesn't do what you think it does. It took me a while to figure that out. So that's the GopherCon website. So GopherCon's coming up, things are getting exciting, people are buying tickets. Thank you all for buying tickets. And now it's time to scale the site. So we don't care what machines these things are on, but what we can do is figure out how many things we have. So we have one replica, so we can scale this thing really quick. There's a scale command. And what I'm going to do is kick it up a notch. How many should I deploy? 100. All are great. So 100 divided by 10 gets us 10. I learned my trick. Yeah, crash the server. It's going to crash. Don't laugh. No, you're not. So what we want to do is bump that to 10 replicas. And what will happen is the scheduler will go out and replication controllers will do what they do. And if things are working, kubectl, git pods, we should see that things are spinning up. Now they should all be running, and the background containers are being pulled, and now all my nodes are actually running, or it's distributed somehow, and I actually don't care. I'm not going to attempt to find out what machines they're running on, but it is being taken care of by the cluster. And these things should be updating, and there's events spewing out for all of these things. So every time something happens, we get events of things being scheduled, when we find a good match, when we increase the size, all of these events live in the system. So now we scale the site, and we can continue collecting money from you all. Now, at some point, we have to do updates, right? Of course, we need to update this thing. And people get fired from their job, and we have to update their title or their role. So we have to update to the site. Hopefully, you guys don't get fired from it because of your talk. But if you do, we will definitely update the site. Let's see. Right. So here's what I want to do. So Kubernetes has all the API components to let us do a rolling update. Again, I don't care about individual servers. I care about cluster state. Let's do one thing here so make sure we have our intent correct. So what I want to do is replace the current site with a new one. So here I'm going to say I want replicas. We'll just do 5. And all I want to do is change the version of the GopherCon site to version 2.0. And now I will attempt to roll the cluster. Some of you are probably like, this is not going to work, it's going to be so fail. Let's hope not. So what happens here is the Kubernetes CTL command client is going through and is orchestrating the replication controllers and killing pods one by one, knowing that the scheduler and replication controller will leap into action and bring us back to the declare state that we want. And we're slowly deleting the other replication controller and bringing in the other pods of the new specification. And it's a fully declarative system, so we just give it these two descriptions of what we want, and we let the API do its thing and roll the updates. So as it's making its progress, and we can probably see some of this in the event log, we'll see what the results are. Alright, so we're getting some events in. And all the stuff that we're looking at, these are all the open source components around here. And if we're sorted at the top, let's see if we're seeing. What time is it? 4:30? So we're seeing the replication controller being created. We'll see some pods flowing here as they stand up. Let's see how far along are we. 6 replicas, 5 replicas. Get on with it. When I say go first, you say come. No problem. So we'll roll this custom. And what we'll do is, oh, good. So now we've gotten our 5 new replicas, and the other 5 don't match our intention, so we just kill them outright. No need to roll those one by one. And we did that over an update period of 3 seconds. So if all of this is working, I should get the new version of the Gopher console. Let's check that out. So it looks like everything's running. So what we need to do now, I should be able to use that same port. Let's grab this port really quick, and we should be able to hit any of these nodes. It really doesn't matter which one. And we'll grab this. Oh, look at that. There's been a change. We're actually announcing the dates for GopherCon 2016.
Yay.
With that, I would like to end my demo. Thank you.